Vivek Kumar, BRCM Behel. Now, without any further ado, I feel privileged to read a brief about our resource person, Dr. Vivek Kumar. Dr. Vivek Kumar has been working as a professor and a head of electrical engineering department at BRCM College of Engineering and Technology affiliated to MDU Rohtak. Since 2007, he has guided more than 50 MTech students. He has given much number of national and international reputed journals. He has been NBA and NACC coordinator in his college. During his involvement in NBA, college has got gold medal in Master of Engineering. It's our honor to be under your guidance, sir. So please, I request you to kindly address the session with your words.
आवाज काफी तेज है मेरी।
एक्चुअली क्या है क्या ये रिकॉर्ड होना है तो इसमें माइक में बोलेंगे तो
She has given brief introduction of mine. एक और ठीक है बंदा नहीं चल रहा है। From electrical science here, electrical engineering. How many from electronics? Good. And how many of you CSC? So for the CSC, it's a very easy things. What I am going to explain, it's just very easy things. Because here it is written already, IOT enable PLC. So when we talk about I am the electrical man. We got it? The question comes from TCP, UDP, then it's a difficult for me to reply all the things because you are all already knowing, okay? If you are asking me from the power system, power electronics, I am very easy to tell all the things. See, I want to give my introduction again. I have done PhD in a power system, then I have done MTech, and I received gold medal there in 2002. Okay, and basically I have done BTech in electronics communication. So I am asking, so I am a man of all. You can say electronics plus computer science, also you can say electrical. Then I have shifted, means power electronics to electronics communication to power electronics, because I have an interest in power electronics. I know you, most of you electronics people know that कि कैसे भागते हैं power electronics से, but I have an interest. Okay, then I have shifted in PhD power system. So little bit knowledge I am knowing because you are more, you can say I have a more experience, that's all. Because knowledge wise I know some of you have a large, vast knowledge compared to me. Okay. So today topic I am going to cover IoT enabled PLC. And one thing is that you people are knowing the NAC and NBA. BRCM just completed their NBA program in electrical engineering August. Okay, I was the coordinator for the NBA in electrical engineering. Okay, so such kind of help if required, I am feel free to ask the question related to NBA or NAC also, because BRCM is both NAC accredited as well as NBA accredited, right? So you already here from 13th of the October, okay, and many of speaker have given so many idea, like the person from PAL, they have given their own idea about IoT based PLC, and I know that many of you, even I am not understanding what he is saying. You are knowing, because the industrial background is a different one, different part from the teaching, definitely. Because my experience is saying like that. Like that, Dr. Dhirendra sir is also given. He is very good faculty from BITS Pilani. He has given so many ideas regarding IoT based PLC. Now you all have already know something about PLC and IoT. Now my slide, what I am going to cover, this is the content which I am going to cover. Introduction part, origin of PLC, means very easy things I am going to cover, so that you must have an interest. You should not feel bored. Okay. Then PLC architecture, PLC operating cycle, one example of hammer mills. Then what are the challenges we are facing in PLC? How the PLC originate? Origin of IoT based PLC. Then history of IoT, IoT terminology. What about the IoT? How IoT took over SCADA and PLC? IoT communication, how IoT works, structure of IoT. Most of you are knowing all the things. Terminology, roadmap for IoT, characteristics of IoT, merit and demerit associated with IoT, why we are choosing the PLC and IoT, then operation flow of PLC IoT, PLC IoT communication model, PLC IoT networking, and why we do need to IoT enable PLC. And last one is the industrial application of PLC and IoT. So I think you don't have any doubt regarding this content. Most of you are knowing all the things. So only why I am coming here to refresh you. रिफ्रेश बटन होता है ना, लास्ट में क्या होता है, काफी डाटा आ जाता है, तो क्या करते हैं लोग, उसको रिफ्रेश करते हैं. तो लास्ट डे है आज आपका इस प्रोग्राम में, तो हम केवल रिफ्रेशमेंट के लिए आप लोग को रिफ्रेश करने आए हैं, राइट. नाउ दिस इज द इंट्रोडक्शन पार्ट. Many of you are knowing that PLC is the, what is the full form of the PLC? Programming Logic Controller. Why the PLC is required? Everything is there, automation is going on, manufacturing process is running, then why PLC is required? See, in a automation, in a manufacturing process, real time data we are not getting. That is the biggest problem related to the industries. And for that reason, the PLC is required. You know, I have written here, see, to control, automate manufacturing process, machinery and various other applications in industrial setting. Second one is PLC are designed to withstand with harsh industrial environment. Harsh industrial environment means, suppose we talk about the chemical mill, steel plant, where the temperature is very high. So the controlling manually control was very difficult. So overcome that, this PLC played very important role. Next, controlling machinery on factory assembly line, robotic system, monitoring and controlling complex process in industrial like manufacturer, oil, gas and other more. Next, if you see, the PLC has been the key building block of industrial control system throughout the whole automation revolution. Next, its role is the command low-level regulatory feedback control loop. If you come to the last line, you will find that PLC IOT allow the flexible development of controller, direct integration with the cloud-based management system, and the effective communication with the wireless instrument. And these three things is required. One is flexible development of the controller, then direct integration with the cloud-based management system, CBM system. If you talk about the CBS system, what is the cloud system? Public cloud, private cloud and hybrid cloud system. So if you see the Google, what is that? That is the hybrid cloud system. And the cloud system is giving the platform for IaaS, PaaS and SaaS. IaaS means for the, they are providing the service for the infrastructure, they are providing the service for the public, and third one, they are providing service for the software. Origin of PLC. PLC is known as a Modicon AT4 and it is developed by the Dick Morley, which is American engineer in 1969. The invention marked as a significant development for the rigid and hardware-intensive relay control and were the prevented at the time. Before that, all the things work on the relay-based system. To overcome that relay-based system, the PLC came here. Okay, and the Modicon 084 later rebranded as a Modicon 184 introduced the concept of digital computerization control, especially designed for the industrial application. You know, if you take the PLC, you are making the software as a ladder diagram you are making. You are giving the control using ladder diagram. What is that ladder diagram? That is only come in the digital computerization control. Okay. So overall we can say that the problem complexity about the relay system is overcome by the PLC. PLC architecture. In PLC architecture, this is the input side, that is the output side, and this is the heart, CPU memory, and that is the programming software. So in this PLC architecture input model, what we are giving here, push button switch, basic switch, photoelectric sensor, and this is given to the memory. And CPU is already you know the central processing unit. They are taking data from memory and they are putting data to the memory as per the requirement, and the programming software is there. And this is indicator. Output is given to the motors, indication, relay, coil. The output is given from this after functioning of this one programming software. This is the PLC operating cycle. How the PLC operated. Then PLC first started. For starting, they are doing self-tested. Self-tested, what does it means? When we are making on, then we will see that whether hardware or software have any fault or not. That initial stage we are doing self-test. Then what we are doing? Input scan, then program scan, then output scan, and then housekeeping. In input state, we detect the input device which is connected to the PLC. Then program scan. In the program scan, to execute the user created program. For the suppose, for example, you are taking the program for the traffic light control system, you are taking for the hammer mills program. So different program are executed with the program scan. Then again we are taking the output scan, means we are making on or off to the system, and then we will communicate it by housekeeping. This is the our PLC operating cycle. This is the one example I am showing here. Hammer mill example model using PLC. Try to understand what is going on here. Raw material are keeping here. It will go to the hammer mill feed agar. Here crashing is taking place. Then again it will come from this side and go from this side that they have not shown, and go to the, if their crush material is there, see here diverter is there. Again if the big material is there, again it will go to the hammer. Here loading is taking place. This is the win level. 1, 2, 3, 4 win level is there. This is based on the SCADA, supervisory control. Okay. This is the one example for the our PLC. Okay. Before that, what happened? If there is no PLC, what is the storage in the bin level? Who will going to be tell you? The person can be measured. There will be one weight machine, and then will be flow this one. That are the problem. Means time taken process is going on. Now, if everything is there, then challenges is also there. What are the challenges? Data exchange, then interoperability, and lack of digital insight. These are three types of challenges we are facing with the PLC. What does it mean? Data exchange. Here it is written that PLC automation network are usually closed loop. You people are knowing that what is the closed loop system and open loop system. Means it is not here. If you are making fan on, that is open loop system. Directly you have to control the fan. But suppose your AC is backside, that is the feedback system. If you set temperature, then what happened? Automatically it is off. After some time, if temperature is go down, go up, it will be, you are not have any control. If only you are using the button and the function is going on. Like PLC also, PLC read all the data as per the program. If program they are not satisfying, then what the thing is that again input is fed, and again your ladder diagram have to change. If you are not getting the if you are not getting the required output, this is the data exchange is the problem. Then you come to the interoperability. What does it means? PLC model, especially the old one, utilizing proprietary data exchange or vendor specific protocol that complicate interoperability. What does it means? What does it means? Anybody have any idea of interoperability?
Only some specific operation available for that particular field.
That, oh, please. घबराइए नहीं आप लोग, आराम से कंफर्टेबल जोन में रहिए, क्योंकि मोस्ट ऑफ थिंग्स यू आर ऑलरेडी स्टडीड. ओके, यू आर गिविंग रिस्पेक्ट टू मी, नो प्रॉब्लम. एकदम कूल एंड काम फ्रेंडली रिलेशनशिप, तब आप लोग लर्न करेंगे. व्हाट इज द डिफरेंस बिटवीन यू एंड मी? दैट इज आई एम 55 प्लस. That is the difference only. What I am telling you, you are more knowledgeable than me. So be calm, cool. एक बार पानी का हाँ, you are right. Interoperability means the exchange of data between different systems in the same language. In the same language. So you are all are knowing that कि languages are changing nowadays. If software की बात करते हैं तो everyday languages are changes. And PLC have a fixed language. So how it will work? So it is a one type of challenges for us to PLC can understand other language also, so that we can perform the different task. Got it? And third one is lack of data inside. Over the time, PLC accumulator minor inconsistencies such as input-output model error or maybe suffered from power outage could directly, indirectly compromise entire control system. To avoid such PLC issue, factory engineers need to consistently and carefully inspect the machinery. Unfortunately, PLC lack system that monitor, predict, and problem from the machinery. What happens when you will work on the PLC? Sometime data which we are getting from that, it will be not convenient for the that machinery, and there is a big problem for that. So this challenges, three challenges we have to overcome. Now you have just understand little bit about the PLC. If you read the PLC, there are too much things in PLC. Now this is the origin of IOT. When it is started? It is started 1982 by Coke machine. Because see, so many speakers have came here, so many things they have shown to you. I know that. But what I want to give to you little bit knowledge. That must you know. Because this is the basic things. Basic if you are not knowing, if suppose Ohm's law somebody is not knowing, how they will apply the Ohm's law in a heater system. But Ohm's law is not applicable for the heater. Okay. So because of that reason, I have taken only simple slide for you people, so that you have mug up something, you must know something. If you are talking to something, you must know IoT, what is IoT, and when it was established, who are the founder of these things. So 1982, Coke machine, Cambridge Mellon University was connected to internet with reported it inventory and temperature control. Concept of internet started from 99. See, 82 and the came into picture in 99. This part is called as research part. Many of you are young. So what we want as a faculty कि कल मैं पेपर दूं, परसों SCI में आ जाए. Many of see that things. See, I have crossed from that line only. Just one paper I have submitted in July 22 and in SCI, and 23 August I have received publication have taken place. 1 year time they have taken, 4 time conjugant में मैंने किया है अभी. Conjugant आप लोग पढ़े होंगे, that is SCI journal. 1 year, 4 time they have given me a chance to change this, change this, change this. So see here, because of that reason I am telling you, आप टाइम दो, छोटा ही चीज लो. Give the time on the research. Our student is sitting. How many students is here? See, final year, third year. Okay, it's a good thing. Third year or second year, you are in doing suppose IOT or PLC based, then it will be very good for you people. So don't do like that. फैकल्टी को तो मालूम है बच्चे कि जल्दी कुछ मिल जाए. इट्स माई रिक्वेस्ट फ्रॉम यू पीपल. खाना भी खाना रहता है ना बेटा, तो मुंह में लेके जाओगे तो भी अंदर नहीं जाएगा जब तक मुंह नहीं चलाओगे. इसको चलाना पड़ेगा. बट द थिंग इज चेंज. द स्टोरी आई एम टेलिंग यू, आई हैव डन एमटेक फ्रॉम NIT भोपाल in 2002. My guide, I have done my MTech project from IIT Delhi under the guidance of Bhim Singh sir. Many of you are knowing from electrical. Bhim Singh sir is the master of electrical. And my background from electronics communication. I have done MTech in power electronics. And my project was transient and steady state analysis of self-excited induction generator. Not induction generator, self-excited induction generator. So what is the difference between them? Self and induction generator. You are giving supply. Self means you won't give the supply. There is a magnetic current, IM, it will take magnetic current and then it will initialize the things. So the thing is that 6 months I have stayed there in IIT Delhi. Then my project have over 9 months total I have spent in my MTech. Got the point? Many of you think about that कि आज का MTech from private university, they are getting laddu even though they don't want to do. Those who are old here, they cannot understand the feeling of mine. So always don't be in hurry. You won't achieve the goal. Okay? So please read, only reading. Make a reading tendency. Minimum 1 or 2 hours you read. Any journal read. The outfit will come. Many of you will say that कि सर ये काम तो हो गया है, ये काम तो हो गया है. बेटा हम लोग 104 पहले 22 करोड़ थे. Got it? Now we will become 140 crore. So situation is very, very tough. So please, the concept of Internet of Things came at 99. Radio frequency identification was observed as a requesting for IoT at that point. One thing again I am telling to all our students, देखो बेटा फैन आ गया है. हम लोग लकली हैं ऐसा कि फैन का निर्माण नहीं किया. हम लोग क्या कर रहे हैं? वी आर रीडिंग अबाउट कि किस टाइप का मोटर लगा है, कितने वैल्यू का कंडेंसर लगा है, यही कर रहे हैं ना. अगेन यू पीपुल आर फेलुअर ऑन दैट. तो वेदर जो भगवान ने हम लोगों को मनुष्य जाति में बनाया है, क्या मैं उसको फुलफिल कर पा रहा हूं? नहीं कर पा रहा हूं. सो बी केयरफुल. ओके, टाइम ऐसे ही वेस्ट मत करना. 2 सेकेंड ईयर में हो, टाइम जाने में टाइम नहीं लगता है. 55 साल मैंने भी गुजार दिया. लेटर ऑन ब्रॉडकास्ट, QR कोड, ब्लूटूथ, डिजिटल water making is used. You know, this ATM credit card came initially. Nobody want to scratch that ATM. Uneducation is there. Paytm जब आया या Google Pay आया, many of you means old people who are sitting here, many of you they never download that Paytm कि मेरा पैसा चला जाएगा. दिस इज ए नेचुरल फिनोमिना नाउअडेज. सी, तो जिसने जिस टाइम पे जिसका यूटिलाइज कर दिया वो मास्टर बन गया, अदरवाइज वो क्या हो गया, बॉटम में रह गया. नाउ दिस इज द ओरिजिन ऑफ IoT बेस्ड PLC. सी, इंटरनेट ऑफ थिंग्स PLC represent more recent development of Industry 4.0. Here, see, the thing is there. I have written here Industry 4.0. That means Industry 1 is there also. Industry 2 is also there. Industry 3 is there also. Now I have written here Industry 4. So what the things will come in your mind? Ki what is Industry 1? That should be come. If the people have that knowledge कि 4.0 लिखा है कोई बंदा, तो 1.0 भी हो सकता है, 2.0 भी हो सकता है, 3.0 भी हो सकता है, 4.0 भी हो सकता है. अगर इसी में वर्कआउट कर ले एक लाइन पे 4 बचपन से पढ़ा है, तो वह उसका सारा सिस्टम चेंज कर जाएगा. लाइफ इज गोइंग टू बी चेंज, बट वी डोंट हैव ए टाइम. तो इंडस्ट्रीज 4.0. नाउ presently industries 5.0 is running in a developed country like USA, UK, France. They are working on industry 5.0. So 4.0, smart connected industrial environment where machine system processes communicate and collaborate seamlessly. The IoT based PLC is natural progression in the evolution. IoT gained prominence in the earlier 21st century. Now this is the things I am talking. Industry 1.0. What the thing is that? Manual production is going on. We are going to use the steam power in industries. Then it will come industries 2. That consists of industries plus electricity. Now what is the result of that? Mass production. Then you come on 3.0. So it will be mass production plus C, computer. Then supervisory control and data acquisition come. What does it mean? Control. Somebody is in the control room and they are operating the things. That is SCADA system. You know, SCADA system and PLC and SCADA, everywhere it is written that PLC is programming and SCADA is, we have to see the data from there. Few years back, when I was some industries. I have an industry experience also, sir. 5 years I have worked in industry before coming to the teaching. So I know that if you go through, again I am requesting to all students, first 1 or 2 years work in industries before coming to the this teaching field. Then you will understand the importance of teaching. If you don't have, like that, if I am asking 7K2, what does it means? 7K2, 7K2 resistance. No, language change, you know. 7K2 means 7.2 kilo ohm. I was also unknown. I thought that what a thing is going on here. 72K, 7414 means you have to go through the data sheet. Practical, you are doing digital electronics, you are doing all the practical. Go through the data sheet, beta. Agar if you want to become a good engineer, otherwise all we come as a degree holder. It's a fact. Go through data sheet. It's my request from newcomer. Even though faculty, new faculty, though who have just joined, go to the, when they are going for the lab, go to the data sheet. That will be very, very helpful to you all. So again now, for which I came here, SCADA plus internet is equal to Internet of Things, and it is the industry 4.0. Again, now I am standing for the 4.0, but here suppose mass communication will come, data science will come, AI, that will be industry 5.0. Got it? Now this is our one history of IoT. It will start from 1982, 90, 99, 2000, 2004, 2007. What happened? Apple smart iPhone variable fleet release. 2009, global start testing self-driving car. Then see 13. So what is going on? That is only research and requirement to the other. And comfortability. That will give you new product. People are now want कि घड़ी में सब कुछ हो जाए. How it is possible? होना तो बहुत आसान है, बहुत टफ है. So read. Only reading can give you a way. 2014, and this Tesla come out with the autopilot drive for their car. Next also is there, but I am not taken. So this is the history of our IoT system. IoT terminology, or you can say JU. वो JU है. इसमें क्या क्या आता है? बिग डाटा, MQTT, इंडस्ट्रीज 4, M2M, machine to machine, SCADA. These are industries 4 relation. Now this C, blockchain, that will in a industries 5. The sensor network, wireless, artificial intelligence, data analytics, this all will the JU of IoT. Means different. JU का मतलब तो दिमाग में यही आएगा कि जानवर होंगे, हाँ, यू कैन से दैट, द वर्ड ओनली सफलिंग, लेकिन किसके जानवर? आईओटी टर्मिनोलॉजी के ये चीज, तो यू मस्ट नो। एंड इसी एमक्यूटीटी की बात करते हैं, ये क्या है? ये प्रोटोकॉल है, दैट ऑल आर प्रोटोकॉल. Protocol means I am standing here. Just what is the protocol? Just I enter here. What you have done? एक फूल दिया इन्होंने, फिर इन्होंने मेरे बारे में कुछ बताया. These are protocol. Basic thing is that you have to understand from small things. प्रोटोकॉल की मीनिंग को जानो, उसके बाद उसको जोड़ो एमक्यूटीटी से, आईओटी से, डाटा साइंस से, एआई से, you will get the result definitely. Next, what is IoT? Are you not feeling bored? Are you feeling bored or getting interest in this? If I am on the telling something to you people, you should not feel bored. Otherwise, it is. See, I know that you have filled up the registration form. You have wounded that you have to sit here. No. If somebody, my aim is that one person is there in front of me and they want to learn, they have to sit here. बच्चों को भी मैं यही क्लास में कहता हूँ, एमटेक में पढ़ाता हूँ, मास्टर में प्रोजेक्ट कराता हूँ, मेरा वर्ड यही निकलता है कि मेरे लिए ये नई बाउंड्री सेट है कि आप सब लोग यहाँ प्रेजेंट. It's my request, if somebody have a something, they can move from here, no problem at all, right? So what is IoT? See, it is a combination of internet plus something. What is this something? That is things. Internet means, many of you are knowing, network of physical objects that are embedded with things. Things में क्या आएगा? Sensor, software, other technologies for the purpose of connecting and exchanging the data with other devices and system over the internet. That is our IoT. Many of you are knowing. But only I am coming for refresh button दबाने के लिए मैं आया हूँ. Now the question is that how IoT took over SCADA and PLC. That is the important. Before that, you have to work, PLC प्रोग्राम किया, SCADA सुपरवाइज किया, गलत हुआ, सही हुआ, एक ही कंट्रोल रूम बना हुआ था, बटन ब्लिंकिंग की, आपने उसको PLC को जाके ऑफ नहीं किया, ब्लास्ट हो गया. अब यहाँ IoT के आने से क्या हुआ कि कंट्रोल इज नॉट ओवर ए सिंगल रूम. कंट्रोलर लेके सिंगल रूम में लोग नहीं बैठे हैं, उसको ऑपरेट कर सकते हैं बाहर से भी. इंडिया में बैठे हैं, IoT के हेल्प से आप अपने फॉर्म को कहाँ देख रहे हैं, वहां भी इंजीनियर बैठा है, वहां जो प्रॉब्लम सॉर्ट आउट हो रही है उसको ये कर रहा है. तो दीज आर द फ्यू पॉइंट आई हैव रिटन. प्लीज रीड इट आउट विथ. See, the industrial IoT came up as a technology which got implemented on top of SCADA. स्केलेबिलिटी डाटा एनालिटिक came to existence with the introduction of स्केलेबिलिटी का मतलब क्या हुआ? स्केल, यार वर्ड से समझो। स्केल मतलब लार्ज एरिया, डोंट कंफ्यूज। Data generated from a SCADA system still act as a data source for the industrial IoT. We are taking the data from a SCADA, but it is functioning from abroad also. You can work on that also. You should not send or email all the things कि ये डाटा है और मैं यहाँ से मेल कर रहा हूँ, कहीं कंपनी जर्मनी की कंपनी है, जर्मनी में मेल कर रहा हूँ. They can see from there also. That help in with the help of our IoT. IoT communication. What are the things? Device to cloud connectivity, wireless short, middle and long distance, radio frequency, infrared, GPS, Zigbee, Bluetooth, Wi-Fi, LP wire, 5G must be there, that is missing here. Satellite enhancement. अब आप देखो चांद पे लैंडिंग करानी है, वो भी आपका IoT वर्क कर रहा है, कम्युनिकेशन सिस्टम वर्क कर रहा है. चांद पे रोबोट को लैंडिंग करानी है, कंट्रोल कहाँ से हो रहा है? इसी ढंग से कंट्रोल में साइंटिस्ट बैठे हैं अपने अपने सिस्टम को लेके, एंड दे आर मेकिंग कंट्रोल फ्रॉम हियर इटसेल्फ. कितने टाइम में क्या ओपन करना है, कितना फ्यूल जनरेट करना है, कब सोलर काम करेगा. सी हमें लोग जैसे एक इंजीनियर बैठे हैं बेटा, उनको भी एक मुंह है, एक नाक है, एक कान है. So basically for the newcomer, mind it. So this is the communication we are using for the IoT system. Now this is the working of IoT. Radio frequency, infrared, then it come to the sensor, then it come to the smart tech, then it come to the nanotech. See, to identify and track the data of things. Working of this is to identify and track the data of things which you want to perform. Then to collect and process the data to detect the change in the physical status of things. The process the data and detect the change in the physical. सेंसर का क्या काम है? सेंसर का काम है डिटेक्ट करना. एक इनपुट साइड में लगाते हैं, एक आउटपुट साइड. अगर जो रिक्वायरमेंट है वो फिलफिल नहीं होता है, अगेन, क्योंकि ये क्या है, क्लोज लूप फीडबैक सिस्टम है, दैट इज नॉट ए ओपन लूप सिस्टम. To enhance the power of network by developing processing capability to different part of the smart tech का यूज हुआ. Network by developing processing capability and to make the smaller and smaller thing have ability to contact and interact. देखो नैनो टेक्नोलॉजी का काम क्या है, चीजों को छोटा बनाना. You know, पहले कंप्यूटर आया था, किसने आविष्कार किया था कंप्यूटर को? चार्ल्स. कैसा कंप्यूटर था? नाउ कंप्यूटर कहाँ है? I am telling about nano. I am telling about nano. Thing is change हो रही है. How the thing is going to be change? IoT can be viewed as a genetic network. कैसा है? जेनेटिक का मतलब होता है बहुत विशाल, बहुत बड़ा. तो IoT जो है नेटवर्क है, बहुत बड़ा नेटवर्क है. This network consists of network or device, computer connected through a series of intermediate technology, RFID, wireless communication. Feeling this sensor act as a primary device to collect data from the environment. Things embedded intelligence in the device through sensor and form the network connected to internet. It makes things realizing the intelligence control. So these are the structure of IoT. Many of you are knowing. I have written only for your. Now come to the technology roadmap of IoT. Starting from 2000 to the, and the time is 23. So it will be, see the roadmap and try to understand. What before that, again which step we again forwarded to this step, then this step. See the software agent and advanced sensor. Here you can write AMI, mass communication, data science. They are working here. And also I am requesting you all, definitely, because many of you from this institute and you all are going for the NBA or NAC, many of in NBA or NAC when you are going, they are asking feedback, FDP. How many of you have attended the FDP? Again, that have a 15 marks out of 1000. Means 700 for the NBA if you go, 700 for the college level and 300 for the your admin part. Okay, department level we have a 700 marks. Okay, that I will explain little bit after finishing this one. Okay, so FDP is very important. I am requesting you all, definitely every month online mode free है, उसको आप लोग जरूर ज्वाइन करें. वो आपके लिए भी बेनिफिटेड है और आपके इंस्टीट्यूट के लिए भी बेनिफिटेड है फॉर द NBA एंड NAC. The characteristics of the IoT. First one is the connectivity. What does it means? Second year. What does it means? See example in front of you. Example is in front of you. They have added, they have connected to me using live telecast or something, laptop, mobile. Every time you are connected. Many of you are sitting also, they are connected. They are someone who is feeling bored, they have connected their mobile to the other things. That connectivity, IoT, what they are doing, that is the connectivity. Intelligence, the sensor they have used. Then scalability, already I have explained, large scale. Then dynamic and self adapting. Dynamic, अपने आप adapt करो. Nobody come to say something. So this problem will come. Some voltage is going to be changed. Then how the machinery is going to be work? After taking from the input from the IoT, they have to change. That will come there, dynamic and self-adapting. Then architecture, बनावट system का, that we are taking care. And finally, without this, everything failure. We have to be focused on safety of, if your data is there. आपका मान लो पिन ही सबको पता चल गया कार्ड का, तो क्या होगा? तो आप लोग के साथ तो कुछ नहीं होगा, हम लोग थोड़ा सा अर्न करते हैं, हम लोग के साथ हो जाएगा. तो दैट द थिंग्स. तो डाटा इज एवरीवेयर इंपॉर्टेंट बेटा. If some company is working, they won't give their data. Otherwise, no need to get the Rafale from France. We can already make that. रफाल से कुछ आया था ना, फ्रांस से कुछ आया था ना, क्या हम लोग कैपेबल नहीं है? But that time it will take time. So we will make that. चांद पे भेज सकते हैं बंदे को, तो रफाल क्या है? But it will take time. Research. When the word come research, everyone is frustrated. Research is nothing यार. वोल्टेज और करंट उसने निकाला है किसी चीज के लिए, हमें क्या करना है? हमें मैटलैब का यूज ना करके हम आईओटी यूज कर लें. पहले क्या था? मैटलैब था. आप पहले सॉफ्टवेयर कुछ यूज किए हो, आप दूसरा यूज कर लो. देन योर रिसर्च इज गोइंग टू बी ओवर. और कंपैरिजन कर लो कि जब मैंने इस डाटा का यूज किया था इस सॉफ्टवेयर से तो ये वैल्यू आई थी, और आज इस डाटा का इस सॉफ्टवेयर का यूज किया तो ये वैल्यू आई है. इवन ओके, योर डाटा विल गिव, सपोज को 10 के बदले में 5 दे दिया मैटलैब से, तो एक खोज हुई ना बेटा आपका, एक खोज हुई ना. बल्ब किसने बनाया था? वो मेड बल्ब. तो क्या उसने बोला कि 100 तरीका से हमको पता चल गया कि बल्ब नहीं बन पाता है. एक तरीका से पता चला क्या कि, तो उसने 101 तरीका सीखा. दैट कीप इन योर माइंड. इट्स वेरी इजी टू से, बट इट इज वेरी डिफिकल्ट टू implement. So I am coming here for giving the motivation only. What I have faced the problem that you should not face in future. That the things. Demerit associated with IOT. See, now the word comes demerit. Always everything don't have merit. I don't have merit. I can't frequently speak in English. You know why? I have studied A, B, C, D in 6th class. I am from Patna. सरकारी स्कूल में ABCD 6th क्लास में पढ़ते थे. तो I have a demerit. But उस स्टैंडर्ड से आज यहाँ पे आके आपके सामने खड़े हैं. Then what I have done? न्यूज़पेपर लिया, रीड आउट किया, प्रोनाउंस किया. कई प्रोनाउंसिएशन मेरा गलत भी होगा यहाँ पे. डेफिनेटली इन द फ्रंट ऑफ न्यू कमर हु इज फ्रॉम द CBSE. But that doesn't means. The mean is that what you are talking does have mean. Got it? So like that, demerit also associated with IOT, and that is one is security issue, other is privacy concern, increase. See, this is the things that is danger for newcomer, and complexity of the system, high chance of entire system getting corrupt. How it is? Got it? Privacy concern, increase in unemployment, why? Every day the thing is going to be changed. When we talk about the digital, ये सो पहले इंडक्शन मोटर था, कंट्रोल हम लोग कैसे कर देते थे? एनीबॉडी फ्रॉम इलेक्ट्रिकल इंजीनियर? मोटर कैसे कंट्रोल करते थे? बहुत सा सिस्टम है, रियो स्टेट मेथड है, F/F फ्रीक्वेंसी कंट्रोल मेथड है, लेकिन आजकल कंट्रोल कैसे हो रहा है? What we are going to use in our labs is a decay. 15 साल पुराना, 25 साल पुराना सिस्टम को भी हम लोग अपने सिलेबस में लेके चल रहे हैं. System has to be changed if we will fight to the other. So अनएम्प्लॉयमेंट आ रही है, नए कमर आ रहे हैं, ब्रेन ज़्यादा शार्प आ रहा है और दे हैव टू लर्न मोर ऑफ थिंग्स. तो अनएम्प्लॉयमेंट चीज़ें हैं. आप ही देखो अनएम्प्लॉयमेंट की बात, IOT सिस्टम आ गई. पहले गाड़ी जाती थी, गाड़ी जा रही है, ट्रैफिक, इंडिया की बात करते हैं, टोल टैक्स, सिंपल एग्जांपल, कितने लोगों को एम्प्लॉयमेंट देता था? टेल मी. अब क्या हुई? सेंसर ने रीड किया. सेंसर सेंसर तो कनेक्टेड है किस सिस्टम से? वायरलेस नेटवर्क से कनेक्टेड है. IOT थिंग इज गोइंग ऑन देयर. So unemployment is there. So every day I have to learn, I have to read, so that you will have to be safer side. Otherwise other will be in queue. They are waiting कि आप थोड़ा सा हल्का हो जाओ, थोड़ा सा साइड हो जाओ. They will go. Now come to this point. Why PLC plus IOT? First one, capacity to remotely monitor and manage industrial process. Second thing, it is feasible to gather real-time data from sensor and other device using IoT-enabled PLC. See, everybody didn't forget. This is the important word. For the case of, if you take the industrial automation, then this real-time data is the important one for the PLC IoT. Easy to automate and improve industrial operation. I don't want to give the example, but example is in front of you people कि ये IoT आया तो कैसे improve हुआ industrial operation. Decrease the downtime and maintenance expenses. पहले पूरी सिस्टम करप्ट हो जाती थी इंडस्ट्रीज में. अब क्या है, सेंसर के थ्रू हर एक पार्ट जो है ना ऐड ऑन है, वो सेंस कर रहा है, आउटपुट दे रहा है. तो मेंटेनेंस क्या हो गई? इजी हो गई. पहले क्या हुआ? पहले के जमाने में पूरे सिस्टम को खोल के फिर उसको असेंबल करके फिर लगाओ, फिर आउटपुट देखो. Nowadays everywhere one by one the sensor is working here, you are getting the data, you are getting the report, so the maintenance becomes capacity to monitor and respond to massive volume of data in real time, and it enable to industrial to strategize the business decision and improve upon the loop serves the with a quality. Now this is the IoT PLC design. It is form of three things: manager, COP, OPC, UA interference. The cloud system is there. They are taking data. We are sending the data from this, and so what is OPC? OPC means open public communication. Open public communication. But these two words is play important role. Before that it is OPC. Now it will come as OPC UA. Open public means your data is not secure. But when it came here, then your data is secure. HMI means human machine interface, and that will be coming to the op area and then to the output. Now one by one we are going to go through that. What is the function of manager? The manager block is responsible for taking data from description of the device and control in the database to initiate virtual device and the controller, which have ability to group together to form control loop. इनपुट डाटा की बात कर रहे हैं. मैनेजर के मीन्स क्या हुई कि आप क्या करना चाहते हैं, दैट इज इनपुट. The manager can modify the control loop at the time of one or more parameters are required to change, or it can be a stop control process without interfacing with other control loop or IOT PLC block. That is input side. If data is going to be changed, that perform in the manager block. Now this is OPC UA connectivity. Try to read. So OPC is the machine to machine communication and used for the industrial automation. That is OPC. And then comes the UA. Connectivity to the cloud is available using OPC UA protocol. There are different kinds of protocol. I have shown you in the before slide. IoT Ju. There MKU, TT is there, Bluetooth is there, so many things is there. So OPC UA connectivity here. There is a UPC. To overcome the problem existing in OPC, we are using OPC UA connectivity. What is the problem there? Open public communication. There will be no safety. Right? Through OPC, you data collect and send to the service in the cloud. Cloud, you already I explained. We have a three type of cloud: private, public, and hybrid. Nowadays, Google, all the things using hybrid. Private, public. A small scale business you are doing, use private. Public domain cloud you can use, then private, then hybrid. Hybrid is the combination of these two. And what are the service they are providing? Three: as, PaaS, and SaaS. They are providing infrastructure, that will come in as. They are providing platform, that is called SaaS, PaaS, and they are providing software, that is called SaaS. So with the help of that, UPC UA connectivity is connected to the cloud system.
UPI is one of the example of tax UPI as an example of task can be taken.
UPA?
UPA.
Yeah, that is the example. That is the example. Google's you take, DataWorks. These all are the example of that. BJAC is the also example of that cloud system, right? That is also an example of that. So this is playing very important role. What I am telling that every part is important. It is not like that it is important if it is not there, other is there, other thing is working. It is not like that. Everything is important, their own importance. Now interface with field device. How it is possible? Read. IoT PLC make the connectivity with the field device on bidirectional interface block that translate data from high level to IoT PLC block to field the device and vice versa. Language is very easy, it will be more understandable. So it is not a very tough one language. You can understand. Basically, those who are from the computer science, they can easily understand. I think they may feel bored also. But for our electrical, it's something new. See, the COP interference. COP means COP is also a protocol. MQTT is also a protocol which we are going to use in the case of IoT based PLC. Will you want break for 2 minutes? Will you want break for 2 minutes? Or not? So if you see the COP interference and if you compare to MQTT, what are the benefit? So when we talk about the COP interference block is intended to provide the connectivity with other IoT PLC. Using the interference, it is possible to exchange the data to device and control and give control command to the IoT PLC such as control loop terminal signal. Then next is data filter. The data filter block gather the information from the interface and pre-process it for later use by the other block. The incoming data stream from the interface block is proceed to the reduce the noise, repair missing data and mask outlier by using filter. Now this is the database. This all four come from you know cloud, manager system, COP system, and the between manager and COP. This we are going to get. Database management, even though device and controller description. For operation, device and controller are represented as a virtual device as a programming object. The virtual devices are intended to be used as a abstraction method, work with the real entities. So I IoT PLC application can interact with data from high level. So these device and controller description are shown in front of you. What they are showing, the resource model used for the IoT PLC as a folder object in OPC and US server with its control assignment. When I am going to tell all the things, this one part is a vast one. If you read OPC UA only, there are so many differences. So it is not like that you have, but it is connected in our PLC system, IoT based PLC system. So become as a master in this, have to read all the things one by one and create the interest. Now you know that human machine interference. So what is the function of that? HMI? Anybody? Already written here. HMI required data, it issue a request to the database block. If you see the first figure, they are giving the request to the database block, and database retrieves the information which is finally present to the user by the HMI. This slide shows the operation of flow of PLC IoT. That is, one word is coke and other is station. Signal is given here and it will be reached to the data receiver end, but before reaching it will follow the PLC IoT network. If you giving the, just now I told you infrared sensor से तुमने signal को भेजा है, and the intensity of that is weakening that, then what the signal is going, first we are going to encoding that signal. Then what we will do, say modulation. Modulation, everyone knowing, small that signal, उसको क्या करते हैं हम लोग, enhance करते हैं, depend upon whether frequency modulation, whether amplitude modulation, that are the type of modulation. And then again the signal is weak. What we are doing? Amplifying the signal, and that is given to the power network, and then for the station same reverse process is going to be done. Modulation and demodulation you have studied, but in IoT based system, that is the advanced version which we have done in the communication system. Many of you have studied modulation, demodulation. The thing is there, coding, encoding, everything is there. The version becomes advanced, and this is the powered network. So operation of PLC IoT is simple from source. See what we are going, the PLC modulation model data signal to be transmitted into high frequency signal through a series of operations such as encoding, modulation, coupled at a high frequency signal to power line through coupling circuit. And at the receiver end, what you are doing? Demodulation you are doing. Then you will get the real data. आप ये बताओ, जब आप फोन करते हो यहाँ से, क्या होता है? हेलो कहते हो, यहाँ से अपने घर पे फोन लगाते हो तो क्या होता है? आप कभी विजिट करो टेलीफोन एक्सचेंज, देयर आर सो मेनी लाइन आर कमिंग, इनपुट, then single output, then again that is converted in output, right? आपके घर पे चला गया, इनके घर पे, at the same time so many people are calling ना, coding, decoding, modeling, these all you must know, everyone must know, because it's a part of things. If you are not knowing the basic things, they have used that basic thing only everywhere. The thing is changes. What they have done, they have used the now artificial intelligence, they have used the data science, they have used other things. PLC IoT communication model. When you talk about the communication model, they have made, you have seen the power line. Then is a physical layer. Then it will go to the media access or data link layer. Then it will go to the network layer. Then it will go to the transport layer. Then it will go to application layer. This is the process that we are following the IoT communication model. Now I am going to explain each of the layer. Physical layer. PLC IT communication signal are transmitted over power line. The physical layer encode and model data pocket that needed to transmit by the data link layer into the carried signal and then send the carrier signal into power line. See, whatever the data we talking about here, transmitting or receiving, that is data what we are getting from PLC or SCADA. That must be distribute anywhere. Before that, what happened? One room is there where the people are sitting together and judging. If कंट्रोल करने वाले को नींद आ गई, पुश बटन दबाना है कि भाई अब सिस्टम ऑफ करना है, थोड़ी सी भी दिक्कत आ गई तो क्या होता था? सिस्टम बंद कर, बॉयलर ब्लास्ट हो जाता था. नाउ अब सेंसर इतने अच्छे आ गए. अच्छे का मतलब यार क्या हुआ? द रेंज ऑफ फ्रीक्वेंसी अच्छे, range of frequency, reliability, efficiency, that will come on that. Response time is a good. And then nowadays, even though you are sitting in USA, you can control from there. That is the IoT. So these are the network, IoT sensor, transport layer, application layer. There are different kind of layer. Read it out and how they are working. One is called CCO, other is called station. CCO, you have just now seen what is the things comprised of CCO? Tell me. Just you have seen in previous slide. CCO comprised of encoding, modulation, power amplifier. Just before slides, I have shown you. See here. That is called central coordinator. And then other is called proxy coordinator. And where the data is going to be received, that is called a station. So see, one is called star networking, other is called tree networking. Where the tree networking we are going to use depend upon the capability, environmental and terminal connection. More industrial IoT can be a star or tree. Where tree topology we are supporting 8 level नेटवर्किंग के लिए हम लोग क्या यूज करते हैं, ट्री नेटवर्किंग यूज करते हैं. क्या डिफरेंस है, सीधे हो यहां पे डायरेक्ट स्टेशन से कनेक्टेड है, और यहां पे क्या है, हमने एक और यूज कर दिया प्रॉक्सी कोऑर्डिनेटर. तो क्या फायदा है इसका, ये नेटवर्क जब तुम्हारा चीजें वास्ट होंगी तो कंट्रोलिंग ज्यादा होंगी. वेयर यू मस्ट हैव ए कंट्रोल in a different mode, that you can use the tree network. Simple industries की काम है, then you can use the star. कि डायरेक्ट हुआ, इनपुट दिया, आउटपुट में काम हो गया, काम खत्म हो गई. और जहां कॉम्प्लेक्सिटी ज्यादा है तो ये फेलुअर ना हो सिस्टम, तो इसलिए बीच में क्या लगा दिया, PCO. Now this is, I think this is the last slide. No, so many slide is there. Why do we need IoT enable PLC? Now the thing is coming, why we need IoT enable PLC? Same word, if you go through in a slide of this, or if you go through Google, same thing. First thing is real time data. It's a keyword. It's a keyword because the industries are working on only on real time data, right? That have to be controlled, and that is written in a different form. See, IoT-enabled PLC establish an accurate power line communication channel in a transmitter model. Power loss, if we talk about the loss in a case of PLC IoT, it's a minimum. Reliability, if we talk about the reliability of the system, it becomes very, very high because sensor is working. Efficiency की बात हम करते हैं, it should be also becomes very, because failure नहीं है सिस्टम, आप फेल्योर होने के पहले ही आप डिटेक्ट कर ले रहे हैं सिस्टम से, तो क्या होगा उसमें, तो लॉस विल बी, बट इट विल बी कॉस्टली वन. Only drawback is that this is system related to IoT based, तो cost it doesn't means when we talk about the, अब अगर आप पावर सिस्टम की बात करते हैं तो जनरेशन सिस्टम की बात करते हैं, तो आप जो मोटर लगाएंगे वो कॉस्टली हो तो भी आप यूज करेंगे, क्यों, फेल्योर हो गया तो सिस्टम फेल हो गई. So that is the things. This is the one example of a smart traffic light control system. This is the Coke plus EC IoT code card. Already you know CCO you already know. That is given to the PLC. Then it is an unified PLC IoT, that countdown of timer which we are giving. Then traffic light is here. And last may you see the crossing button. That is the station. That is the same thing what you have written, we have written there, Coke, CO, and that is elaborated form of that with the one example. This is the smart street lamp. See here. See here. Heavy crowd vehicle. Light crowd vehicle. What happened here? Brightness is 100%. Here brightness is 50%. But how it is possible? Coke, CO is huge. Sensor is huge. Then after that, control is huge. Smart home. What does it mean, smart home? It's very easy, yaar. You can explain the things. स्मार्ट होम, स्मार्ट सिटी कैसे बन रही है? हाँ, यू हैव टू कंट्रोल, मीन्स इज जो भी एक कंट्रोल आप बैठे बैठे कर लो, दैट इज कॉल्ड स्मार्ट. एंड वी आर यूजिंग PLC IoT ऑल्सो इन स्मार्ट. यू वोंट सी दैट कि ऑटोमेशन है तो बड़ी फैक्ट्री में केवल PLC लगी होगी, ऐसी बातें दिमाग से अब निकाल दे. क्या है PLC? देखें साइज, ये थोड़ी है कि PLC सुनने में ऑटोमेशन फैक्ट्री, द वर्ड आर वेरी बिग बिग, बट द आउट PLC दिस वन फॉर एनी कंपनी. मित्सुबिशी का भी ले आएंगे. कौन कौन सी कंपनी है PLC के लिए? सीमेंस, जेनिक, देयर आर सो मेनी कंपनीज. PLC का मतलब ये नहीं हुआ बेटा, बहुत बड़ा भास्ट थिंग्स है. मेमोरी वीट खाली देखना है. सो आई वांट टू नो कि जो ट्रेनर आए थे उन्होंने क्या बताया था आप लोगों को? PLC के ट्रेनर भी, उनका भी वो था ना, वो उन्होंने क्या बताया था? कोड कैसे जनरेट करना है? ओके ओके.
We design different ladders on that. Logic ladders are there, sir. We design different logic.
Okay, हाँ, different logic. Ladder diagram is there.
Yes, yes, sir.
They have run that.
Yes, sir.
Here itself or in.
We implemented there.
हाँ, means code PLC, that code working model you have understand there ना? हाँ, कैसे run किया जाए. I am only explaining the things. What is that behind that? Because I am not a trainer. This is the smart home. See, everything is controlled. Everything is control of this home. Smart agriculture. Everywhere. Where तुम नेट पे बैठे बैठे एवरीथिंग कर सकते हो nowadays. Smart agriculture market now becomes that much. अब स्मार्ट का मतलब क्या? आपकी सेंसर लगी हुई है सॉइल में, आप कहीं चेक करना चाहते हैं कितना प्रोडक्शन वो दे सकता है, वो जो मिट्टी है नमी कितनी है उसमें. That are all work on IoT based nowadays. The thing is going change now. अब यहाँ पे आप पिलानी में जाओ, water level is very down. Because I am from nearby only, from 20 years I am, Bal is very near to you. I am working there from last 20 years. So it's a very, I know everything about Pilani. My friend is working in WITS Pilani. Healthcare. See. How it is working? You are sitting here, system is working in the system, hospital, you are a doctor from USA. They are not asking the patient should go there. There is a monitor. Same what the thing, here it is visible in front of other doctor in India. Same thing is visible in USA and treatment is going on. That is the smart health system. Now this is our last slide. Future trend developed in the IoT enabled. First one, AI and machine learning. That I am repeating again and again repeating. 5.0, industries 5.0. That is based on AI. So you can work on that also. The new faculty can work, they understand the IoT and then go for the AI and machine. See, conventional में electrical में कुछ नहीं बचा है मेरे भाइयों. If you talk about the conventional system, कुछ नहीं बचा है करने के लिए. It's a fact. कि मैं ये थीसिस कर दूंगा, ये प्रोजेक्ट कर दूंगा और ये कर दूंगा, नहीं बचा है. I have to be read these things. And you can do so many things. Number of paper you can present. So little bit advancement is required from all the newcomer faculty, those who have joined. They know AI, they have studied already. See, nowadays people in IIT, people are people like Bhim Singh sir and others also studying that AI and machine learning, all the things. I have talked few years back, I went there. They are saying that Vivek, you do that work now. Forget all MATLAB and all the things. It becomes outdated. So work on that. Add other department you must add to the your electrical. Again I am requesting you all, electronics, computer must make a paper and collaboration with the mathematics faculty. There are so many options. कंप्यूटर वाले अगर मैथमेटिक्स के फैकल्टी के साथ अच्छा कर सकते हैं ना, उनके पास बहुत पेपर है. इलेक्ट्रिकल वाले एआई और एमएल कर सकते हैं तो आप बहुत कुछ कर सकते हैं. अदरवाइज थैंक यू फॉर पेशेंसली हर्ड एंड गिवन टू मच टाइम टू मी. थैंक्स अ लॉट अगेन.
Thank you, sir, for your valuable insight. To show our gratitude for Mr. Vivek Kumar, I would like to call our FDP coordinator to present a memento as a token of appreciation.
थैंक यू, थैंक्स अ लॉट. थैंक्स. ये now the thing is over now.